Welcome back to another video on Goliath where we're enabling Bluetooth to cloud on different vendors' hardware. I'm here with Mike. Hey, Mike.
Hey, Chris, how's it going?
Good, good. And today we're going to be going over the Arduino Nicla Sense. Is that the right terminology?
Yeah, I think Nicla Sense ME is what it says right on the board. Fresh from the DigiKey. We have this wonderful board, and it's tiny. So exciting.
How tiny is it?
Postage stamp size.
Yeah. And it does have it has castellated edges, but then I think they also meant for it to be like you could potentially have a cutout and you could like solder it down. It is a two-sided board, I remember. But
yeah, I looked up the instructions, and it seems like there's some carrier board that I hadn't heard of before that's like the same width, but it's longer that this can go on top of. But I'm excited because it's got a Nordic Bluetooth chip on it.
Right. And that means basically we're kind of already halfway there versus some of the other vendors that we're enabling here. So Arduino is a board maker. They have an ecosystem. People know them from their development boards, educational content, all that sort of stuff. They make it easy to talk to different pieces of hardware. One thing we've been excited about is that they're also recent recent people that have joined the Zephyr project as members.
Yeah, so super exciting. We see better and better support for the Arduino boards through that support of the RTOS. And this board, in addition to, we're going to try and connect it to the Goliath network over Bluetooth today, but it's also got some sensors on it. So I think if we have time at the end, like we did last time, we should try and get those sensors streaming data.
I think that's right. Yeah. And I think that's because of their partnership with Bosch. They have a whole bunch of Bosch sensors on there. We have one Bosch sensor that you and I use all the time, the BME 280, but Bosch makes a whole range. Sensor Tech, the group within Bosch, makes a whole range of sensors. And really that's one of the values of this sort of board versus, a more traditional, just a development kit from a silicon vendor. Usually it's like focused just on the silicon, lots of breakouts, maybe a programmer, maybe once in a while you'll see some sensors. I feel like that is the trend a little bit more with the STM32 board we did last time had that. But, then it's often up to non-silicon vendor boards to bring it kind of all together. And this is really meant as a sense system, right? Obviously it has sense in the name. This is meant to pull a lot of sensors in to build out that ecosystem and make it a drop-in for industrial sensing and similar. All right, where do we start?
Well, we're going to start with our Bluetooth, which is still in early access, which is private. However, if you seek us out on our blog or our webpage, we're talking about it everywhere. So you can probably find it easily enough. You can sign up for the early access, right?
Yeah, there's probably going to be a QR code here. There's a link down in the video in the blog everywhere. So yeah, lots of different places to do it.
And so I think what we're going to look at first is just getting this board to work with Zephyr. So I have Zephyr docs up here. And I can search for, let me spell it right, Nicla Sense. Should be enough. There we go, Nicla Sense ME. So I like to come here because it tells you what the West board name is, which is important. And then I can see that it's running on an NRF 52832, which we should be able to use with the vanilla Zephyr, which I already have set up here in my BLE private access. So I'm going to go out of the application directory, and I don't know where the Zephyr is in this. Oh, there it is. It's in the depths. Depths, Zephyr, samples basic Blinky. So that's what I always like to do first. And I should just be able to build for this. -P-B, and then the name of the board, which is Arduino Nicla Sense ME. And okay, so this is DTS for LED 0. So this board probably doesn't have LED 0 defined. So when that happens, then I run hello world. So we can run like the same command. And then that built. Great. So then we can try West Flash and see if that works. I got to plug the board in first. Let's see. Oh, USB. Is it C? No, it's mini.
This is on the Arduino board here as well. So I had assumed that this top left was maybe that's a user input button though, up by the module here, Mike.
Oh, see the red light is so bright I can't see it. That button next to it.
Yeah, yeah. And this is good too. We should have looked at this as well because it has this interesting module where it looks like the antenna is facing inwards. It's a very non-intuitive design on that side of things. So reset button. Mike's talking about this red LED in the upper left here. And then all the different sensors, accelerometer, gas sensors, things like it. Backside, USB micro with a 5-pin header. Looks like a programmer, an Atmega programmer, and then some other. I mean, this thing is teeny tiny, really.
Yeah.
Diminutive as needed. Because I think it's what?
Yeah.
25 millimeters across or 1 inch across.
I'm going to let you do that estimate. I'm a poor judge of time and distance. So what I'm doing is I'm just going to go and put in a delay and have it print out this message over and over again. Let's say I probably need include, what is it, Zephyr kernel.h. All right, so let's try that. Should rebuild when I try to flash it. Here it's flashing. There we go. All right, so I suppose I could have just reprogrammed it. We were just missing it before. So like I was plugging it in and it wasn't enumerating. So this is good. So now we've confirmed we can speak to the board. I usually do this with the Blinky because then you don't have this problem of like catching the start of it, but it doesn't have the LED on here. I think is RGB. So it's probably not as straight up like twiddle a pin. Yep. Let's see. All right. So that works. I think the next thing that I like to do is I like to spend a lot of time in the Zephyr tree before I move out to other projects because the Zephyr tree should be like the source of truth on things working. So let's just build for the Bluetooth beacon. And this is where it'll usually fail, like if you don't have your binary blobs downloaded and stuff like that. So that built just fine. I don't feel a need to actually run that. I just wanted to make sure it would build the Bluetooth stuff. And then let's go into our pouch examples. And let's see, just going to look up the build commands. So some of the stuff that we're going to need to do for this one, we need to have a gateway going. So I have a gateway already programmed here, but it's not plugged in. So I'm going to do that now. And then the next thing that we need to do is actually create a representation on the cloud for this device. So if I go into my BLE private access project, so this has been opted into the Bluetooth. You see this network shows you that it's been opted in. And I'm going to create a new Nicla Sense ME. Very creative names. And what we actually want to get out of this is just the device ID. And that's because this device is not going to directly connect to Goliath. If it was, we'd need to have some kind of credentials like these PSK, PSK ID, or a certificate. But in this case, the device is going to connect through a gateway, and it's going to use a device ID to, show its authenticity with that gateway. So here, I'm just going to put that device ID in the instructions, in the build instructions. They have this command, and at the end, you can see they're adding an extra kconfig symbol, and you have to replace it with that device ID. So if we go in here, all right, so there's that device ID. And then also I'm copying from a build command for a different board. So I need to put my board into here.
As you're doing this as well, one thing I wanted to point out was we've had some questions about the size of the Bluetooth SDK and similar. And, as general guidelines, Mike and I have built for the NRF52840, which is a megabyte of flash and I think 512 RAM. And then it kind of steps down in like half steps, I believe. So I think this one is 512 flash, 256K RAM. I'll double check on that. And then, so that's like, so 52840, no problem. 52832, no problem. Then kind of the lower tier, like the high volume commercial level stuff, like the stuff that might go into like seem like Bluetooth pregnancy monitors, like throwaway kind of stuff, which is wild in its own right. That's usually getting to those points where, flash and RAM are so constrained that we don't really recommend it. So this is right now, before Goliath does more optimization on the Bluetooth side of things, I feel like this is a good kind of lower tier, upper tier. Obviously, this is the older version of Nordic hardware as well, but
yeah. So right now. I had a couple of nodes running earlier today that are not this node. So you can see they're not bright red. I think if they were bright red, it would show that data is flowing right now. Not quite sure how that goes, but if we flash the board, we should now see. Oh, look at that! It sees my gateway and it sees the Arduino, and luckily it tells us like use 0 for the Arduino. That's nice.
Yeah, I think some certain runners as well will detect based on like build names and stuff like that, right? Like the NRF util, I think, does that now, but I don't think this other one does.
Yeah, I've not used PyOCD very much. I think I used it for some NXP boards before. All right, let's see. Advertising successfully started. So that looks good. There's some netbuff timeouts. Not sure what those are all about. There it goes. All right. So I didn't do anything. I was just waiting for like the regular harvesting of the gateway. And now if I refresh this, hey, yep, you can see this is a more vivid red, and it's going faster too. Some nice design from Tron there. And then if I can go into, let's see, I can go into the gateway and it'll show me the devices that have connected to it. And this one's our new one. And you can see here connected a few seconds ago, or a session established a few seconds ago. And we're getting our stream data of 22. So another successful Bluetooth leaf, Chris.
I mean, Mike, you're like making like a tree and leafing. So normally at this point in the process, when we're enabling Bluetooth to cloud boards, we would go and dig into the sensors, and we did that actually for this one. Interestingly, as the hardware person, I'm going to get to show you some of the interesting hardware that's on board here. And so this is the schematic. It's all available online. Arduino's great with sharing their stuff online. And so there's 3 sensors that we are interested in on here, the BMP390, BHI260AP, and BMM150. And so usually when we're doing stuff at Goliath, we're doing things with Zephyr that have Zephyr drivers. And if there's a driver in Zephyr, it's usually pretty easy to get that stuff together. And in fact, there is one for this BMP390. Unfortunately, it's all hooked back through this kind of sensor fusion chip. And you can see it on the schematic here. So we've got the pressure sensor here. We've got the BMP390L, the magnetometer BMM150. These are actually going back through the accelerometer BHI260AP. And as far as we can tell, that is not yet supported in Zephyr, and so we kind of bailed out on that. I thought I'd show it here because it's interesting. And this is great hardware, and this sensor generally is very, very complex, and you could do a lot of cool things with it when you're mushing together all these, pressure, magnetometer, 6 degrees of freedom IMU, all that stuff together. You could basically really know where you are in 3D space, but because of that, the sensor driver is much more complex. So definitely some cool stuff there. We didn't, when we were recording, we did not hook together an external sensor, but just as easily we could hook in similar, like these are all Bosch sensors, we could hook in a BME280 or other ones. We just didn't do that when we were recording. So other things that we're going to be showing in the future for Goliath, other boards, other vendors, other sensors, all of these things are Bluetooth capabilities, basically low power boards that have a lot of processing that you're going to want to go back through a gateway up to the cloud. If you're doing sensor fusion, you want to publish that stuff back to the cloud. You probably don't want to write an app yourself. You do want that data somewhere on the cloud. That's really where Goliath Bluetooth to cloud shines. So if you're interested in that, check it out down below. You can still sign up for our private access, see some of our early capabilities like Mike was showing here today, and we're excited to show more Bluetooth capabilities here on Goliath. Thanks for watching.